lecture that I'm doing to probably see some of the recurring protagonists. So Miss Vandero is one of them. So so you see, Miss Vandero said it's all in the details. So if you start to understand what exactly does Miss Vandero mean, what exactly is God, is there God in this world? Probably in this room it is highly contentious. So what exactly do we mean by God is in the details? So when Miss Vandero said it, probably that he has this fetish towards the detail aspect of it, but what exactly do we constitute an architecture detail to be? So it is concisely expressing the details in construction. Because architecture and construction, they come together hand in hand. One is unable to separate this is construction, this is environmental science, and this is architecture, because everything must come together in a coherent way. And probably you can remember this is one of my favorite talks. There is this book called 101 Things You Learn in Architecture School, and it is quite an interesting book, but this is one of the interesting things. It starts to define what we have tried to avoid at all costs, to define what exactly is architecture. So the author of this book, Matthew, has defined architecture having two definitions. The first definition is an architecture is an exercise in truth. So whatever that is deemed of necessity, it is then expressed as an architecture, is also expressed as in society, expressed as power, expressed as politics. So architecture is this crazy shit. So a proper building is therefore responsible to the universal knowledge and is only honest in the expression of its function and of its materials. So this is something that is probably highly subscribed to because most of your teachers, like me, we are infected by the modern poison. So we tend to have this idealistic idea where everything should be a certain honesty. So that's that. So the first part of architecture is that architecture is honest, architecture caters to our needs, and architecture has this moral responsibility of being honest. Number two, architecture is then an exercise in narrative. Architecture is also about telling you a story, and it's also a canvas for relying social myth, and it's also a stage for the everyday life. So there you see two contradicting ideas about architecture, but all in all, the two must come together to form a coherent picture. So, but what is more important, at least for today, is this aspect. Something to do about materials and something to do with about its functionality, and then how through the idea of a 1:20 section we are able to express and to talk about issues like this. There are some slides that you guys have seen it before, so this lecture I didn't attempt to edit it. I only threw in one or two slides, so some slides you've seen it before, so I'll run through that. But even though when we talk about architecture, most of us, we focus on the big things. We focus on how the ideas have been generated. In the discourse of architecture, we talk about how the form is generated and how the idea comes across. So that is a very broad view of architecture. But most of the time, we have neglected the idea of the small things, the idea of the micro. So, but most of the time, it is when you understand how this building is being put together as an idea, it is that level of the detail helps to strengthen the architectural project. So it is also an extension of the design process to strengthen the concept that you may have. So we went through this, we went through this, we went through this. So it is worthwhile seeing this again because to be able to detail, it is to respond to the specificity of the site, which we'll be talking about that later. So we talk about this, we have to talk about this. So details are important. I forgot to tell you that this lecture is not exactly MAT lecture. It's slanting towards MAT, but it's always with the lens of understanding design. So it is seen as a design lecture. So what are details? So are details just drawings that allows the contractor to build the building? Is it a set of drawings that you just draw and then you shove it to the contractor's office? Hey, come build it. I'm the architect. I'm the master builder. You have to follow what I'm doing. Or are details the boring stuff? You know, after I've got all the spaces resolved, give it a crap. I'll just do the boring stuff and do the contractor as well. Or are details only drawn by the engineers and the contractors? Or are details all the boring, all of these lines, all of this complicated stuff? Or are details just, when the design is completed, then you shove up your time to draw the details? Or as what Ms. Vendor has said, a detail is like a church of today where God dwells. So architects, we focus on the big things. So we talk about how this building is being built in terms of its spatial relationship. But most of the time, when you're drawing drawings like this, or when you're drawing a floor plan and 1:100, we are just talking about representations. So plans are representations. So needless to say, a drawing is also a piece of representation. But do keep in mind that if you pass these drawings to the contractor, you tell the contractor, hey, Mr. Contractor, can you build this to me? I want this planter box, all this window that's popping out of the facade. The contractor will probably scratch his head and say, no, I don't know how to build it. Because even with this level of detail, the contractor will say that no, he's unable to build it. Because all of the detailed drawings, how the different layers come together, how the bolts and the nuts come together, we can have to say. It doesn't mean that we are so egomaniac as like the master architect. It is because that as an architect, you have the moral responsibility to understand how this building is being put together and how it can be constructed. That is our moral responsibility. Do not leave this to the contractors, although the contractors sometimes will probably have a better detail than you. But to draw a drawing at a larger scale, it conveys the idea on how things are being put together. And as a construction site, because if you have ever went to a construction site, you have understood that the construction site is a very unforgiving place. Mistakes are always there, and it's so messed up, it's so busy, and every time you go to a construction site, the next morning you end up with a trembling headache because it is that headache. So the construction site is an unforgiving place. It is when mistakes occur terribly. So coming back to architectural details, so the basic idea is about designing how the different elements come together. So of course, whenever you talk about putting things together, you can't run away from the Vitruvian triad, which is to talk about functionality, stability, as well as aesthetics. So Vitruvian's ghost has never left the world, and it always will be looking around us. Just corner of our lives. So a detail, at least from the dictionary, it is defined as a mini part of a larger whole. So when I say that the detail of this, that means it is trying to structure what the entire picture might be looking at. It also connotates the quality of certain intricacies, and most importantly, it has to be specific. A detail is about craft as well. It's also about how you join things together, and it's also about how the facade comes together as well as the interior fitting. So all in all, we are talking about materials, what materials to use, on what basis we are choosing materials, and what are the considerations that we need to think about when we are selecting the materials, with reference to the construction method. So this is probably a drawing that you guys should be working towards. It's the level of scale, the level of detail. That means I'm able to understand more or less how the construction is going to be put together. So all in all, it tells you a lot of information. It tells you the information on how the building can be put together, so that the contractor is able to, first of all, to cost. So let me know that this building is going to cost how much it's done by So architects will churn out drawings like this, but you can never say that this is for construction. In some architectural drawings, you'll see a stamp over here for construction. That is never to be issued from an architect's office. So when you're drawing drawings like this to a level of this detail, we call this as a set of working drawings. Because whatever drawing you push out from the office, it is a legal document. That means if something goes wrong, the contractor will take this piece of paper and sue you. So we call this the working drawing. Because working drawing gives it a certain ambiguity, so that it is to protect, so that you don't get sued. So we call this as working drawings, not construction drawing, although it more or less means the same. They are often, so the idea of construction drawings, the idea of working drawings, in contemporary practice, it is always relegated to the tail end of the process, and that gives us a lot of problems. Because then we have this mentality that, so once you have resolved the spaces, then we talk about the details. But what I'm trying to tell you, at least when you move up to the third and the fourth year, is to understand details as part of the design process. So whenever you're talking about the construction of the spaces, understand how the spaces relate to one another. The next step is to understand how these are being constructed. So that when you move into the process of trying to detail your buildings, you will probably have less problems or less headaches to deal with. So for some practices, detail development becomes relegated to an exercise of collecting specifications. So this is also hopefully not the way where you collect all the standard details from this Flying Panda brand, you get this wall detail from Set Lizard brand. So it is not simply a collection of the standard details, but it's to understand how these standard details work, and you move the elements around it to achieve what you want to have. So the question is that, oh my god, what is it that you want to have? So hopefully this lecture is going to cover it a bit later. So the traditional idea is that I have the grandeur vision of the building, I do up the floor plans, and then I end up with the details. So it becomes it's delegated to the tail end. It is almost like say, oh, this is so boring stuff, I'm going to leave this as a production mode. You know, you leave it to the technical stuff, you know, then you go on to design. So this is probably not an idea that is should be inculcated. It's not an idea that it is inculcated in schools. So this is terrible. So because this traditional method of seeing details as the least important aspect of the design process, it is then terribly outdated. Because it is impossible for an architect to possess all of the necessary skills. From the onset of the process, you need to understand how these things are being fixed together. That's one. Number two, you need to gather necessary help to help you to resolve the building. So we are not just talking about design skills, we are not talking about the detailing skills, we are also talking about a lot of skills that you will be able to inculcate in the process of education as well as in the process of practicing. So as an architect, you rely on many individuals coming together to harness the specialists and skills of that individual. So it's highly collaborative. But the idea of collaboration is seen as a buzzword in recent years. So many a times we talk about collaboration, but actually we meant cooperation. So there is a vast difference between collaboration and cooperation. So the ideal stage, but it's not so relevant to you guys because you guys are young, you guys are year one. So I'm talking about when you move on to year 2, year 3, and your university. Think about the process. When you're resolving the spaces, at the back of your mind, thinking into how this is going to work. Okay, it will save you a lot of time. And so you have now, this is what is missing in the process. It is to try to resolve the detail. Understand how this ID is being put together, understand how the configuration of the ID, in your case, you're not supposed to use ID, and understand what are the possibilities of how do you join the aluminium windows, how do you bolt it towards the ID. So these are considerations that you need to entertain at the beginning of the process, so that at the end of the day, you're able then to carry it out in a very coherent way. So each shift in these details will give you another perspective that will have an impact on the architectural qualities. So don't leave it to the contractors, don't leave it to them, because you never know that they are able to screw up everything that you thought that can't be screwed up. So the thinking of the construction details springs off from the moment where you have started to visualize architectural spaces. When you start to understand, think about what materials you can use to fit out the space, what materials you can clad your buildings around it, and that is the beginnings of the startings of the thinking about the architectural detail. Because the details are the process, and the process, they are architecture itself. If you start to think about architecture, it's not so much an outcome, but architecture is the process of thinking through towards an outcome. So the process of thinking through inevitably thinks about the bolts and the nuts, and how you are able to assemble this building together as a unit. like in this manner, the architect, you can probably tell who this architect is. It is that he has thought about how this wall is able to support this fixture, which is then having this steel profile here that's bolted towards the wall, and then you plaster and paint over it. So this is a couple of sections that you have to use welding to do it. So you have a plate, you have another one, and another L-shaped stick. So this is a highly customized detail. So this is something that you are unable to source it from Flying Panda brand or Set Panda brand. So this is a customized detail. And then how the louvers are orientated this way, and how the sliding straps over here sits on this timber piece over here. So these are the intricacies of it. So this L-shaped thing that you see over here is a roof. And there's a rebate over here to receive so that this is flush. So everything, every is accounted for and carefully considered. So basically there are two main types of details. The first way of approaching details is to understand how do you express the detail. So you have to express how do you express it, and then how do you conceal it. So both are important, but it tells you which aspect that you are moving towards. So I'm going to elaborate on what exactly do they mean. Expressive details tells the story of its purpose. Remember the 101 thing? So it tells you how this building is constructed, and how through the orientation of the fins and the louvers starts to give you a hint on its orientation, of its locality on the site. So it tells you a story, it tells you its own making, it is almost an autobiography of the building's construction. So when you look at the construction, visually you can start to understand how the bolts and the nuts come together, and it tells you a story on how this building is then being constructed. So details are also cultural as well. So in Singapore we don't have much culture. Our culture are mostly influenced from the West. They are very Western centric, which is then quite problematic. Anyway, as a counterpoint to the expressive detail, belonging to the realm of the concealed detail. So this is like concealed detail, like the ceiling boards that you see over here. These are highly expressed. You could see the hangers, you could see all these elements coming together. But sometimes you see a false ceiling with a plain panel. So that is a concealed detail. So concealed detail are usually relegated to the task of performance. So there is something that is not to be seen, something that you do not want to express it out. For example, the fixing of a partition wall or a suspended ceiling. So this is London Aquatic Centre. It features a very capacious form. It is crazy. So let's zoom in at this detail because it is nothing pretentious. So the concealment comes when you wanted to express this form, it is purity. So you could see this form, but the detail, oh my god, it is crazy. So whenever you want to understand a drawing, the first thing you understand is the scale of the drawing. So how do you ascertain the scale and the proportion? Simple, look at a human being. Which is why in all of your drawings, it is good to draw in the human being because it allows your teachers to see the scale of the drawing in relationship to the human being. So when you see this, you understand that my god, this is cantilevering at this 10 centimeters. If this is about 1.6. So you look at the intricacies of the detail, so you can almost see the construction. You can see the insulation panels. You can see it is made of metal roof, it's not concrete. And you could see the complex steel structure. You could see almost like the rafter-like thing that's coming out down over here to support all of the steel or aluminum cladding over here. And the elevation goes down like this. So this is at a scale. So we are going to zoom in a little bit further to look at this here. So it tells you a complete picture on how this building is being built. So you see an insulation, you see like a scupper drain over here, there's to be drain somewhere. You see the presence of the I-beam on this section and an elevation, and some crap that is over here that no one exactly knows what's happening anymore. But the structure, it is crazy. So even with a very sensuous form that is seemingly not pretentious, but it tells a story of complexity. So it tells you that concealed details are not necessarily the nicest thing, but it is there for a reason. The forming is wrong. So, like for example, in this cantilevered staircase, it is also an idea of concealment. So you could barely see the construction joints. There is no hint giving you on how this staircase is being fixed. So there's a lot of guessing game. Is it cantilevered out of mouse steel, or is it David Copperfield or David Blaine doing his work? So the support you then conceal. So then it becomes very expressive into a certain extent. So the other way of expressing detail is that it reveals how the staircase works. It reveals how the tracks and the risers are being supported, and it carefully reveals how you needed two thin elements to support this heavy looking track over here. So you see some ideas of expression, like this is almost like you guys are creative of Tetris. So it is simply about slotting in, using a very light expression of lines, supporting a heavy element that is then going back to this screener beam that is on the side of the staircase. So highly expressed. So we are going to talk about the meaning of details and as well as the purpose of details now. So architectural details is also an extension of the design process. It is extending your main architecture ideas into microscopic aspects, so that when we are looking through the details of what you are proposing, we can sense and then remember the hints of your main architectural ideas. So it is an extension of the design process. Architectural details also tend to reflect the cultural background from where they're coming from. Sadly, it is not so well reflected in Singapore, but we do sense certain construction that is relevant to our climate and our culture, especially Asian cultures. So details are also a reflection of who you are, of who I am. Most importantly, it reflects that space or a specific locale. So then the next question is that would the details be designed to go coherently with architecture? That is probably yes. Would the details to be designed have to be fixed or rather to be constructed easily? Do you think that details need to be designed to be fixed easily and feasibly and of course at a cheaper cost? Will the details be able to weatherproof and to be able to let the rainwater run off? Would the details that you're designing take into account of the construction method that is relevant to our context of having a lot of water, having a lot of heat? And would your details allow the natural influx of daylight? Would your details allow the influx of natural ventilation without the rain splashing into your building? Most importantly, will your details be able to stand the test of time? That is probably relating to Zaha difficulty also. Because we have to think about all of these questions. We cannot leave all of these questions to chance. Because the last thing that you want when you're practicing is the failure of your details. Because even Corbusier says that there's no details in architecture. So this guy basically takes a step back to say that why are you even discussing about details? Why do you need to give a lectures about detail? Because there are no details in architecture. It is architecture itself. Because everything is important. So the next part of the lecture, it is trying for me to unpack five or six principles which I forgot in ways on how do you approach the design process in terms of its details. So we spoke about this a little bit, details as an extension of the process. We talked about the function, we talked about its materiality, we talked about its honesty in its creation. Number two, constructability. Are you able to make your detail work? We are talking about construction tolerance and maintenance, and even to the size of the material. We are talking about, in terms of design, actually this lecture comes from a student asking me a lot of questions. So it seems that my lecture is able to answer this question anyway. So when you select materials, on what basis are your selection? Is it based on phenomenology, or is it based on practicality, or is it based on this word called nice? In fact, it's everything. Is it about user engagement, or is it about depth comfort? the next point talks about is relevancies within its context, because you are going to design for a building in the tropics. So what are the approaches of designing buildings in the tropics? We talk about water, humidity, and the movement of the air. And the last part is to talk about how then do you understand precedent studies in relationship to the architecture features. So all of this, they are not sequential, and all of this, they are interlinked, interdependent from one another. All of these are important. So number one is the extension of the design process. As you move into the stage of doing a 1:20, remember your architecture idea and to ask yourself, how are you able to extend these architecture ideas into the design of 1:20? It seems to be pretty abstract, but it can be done. Hopefully some examples. So we're talking about these issues like this. So we have seen this before. I'm going to because honesty, the idea of honesty, no matter how fast you run, you are unable to detach from the goals of the modern era, because that is the underlying agenda of the modern world. We spoke about this. I'm going to run through very quickly. We spoke about this handsome guy. We spoke about this. We spoke about this. We spoke about this. We spoke about this. We didn't speak about this. So. Inspiration. Inspiration is a very strange word. I think it's highly contentious. But this slide is not about inspiration. It's about this thing called laminate. So this is a brand called Lamitech. So laminates are what you see over here. Okay. So it tells you, it shows like a timber grain pattern. But when you touch it, you know that it is somehow synthetic. It is somehow plasticky. So these are laminates. The floor you're stepping on is not laminate. It is vinyl. So these are like for example, vinyl is a synthetic material. It is so the floor that you're stepping on right now, it is vinyl pretending to be timber. So it shows a timber grain, but it doesn't reflect the properties of timber. So with every lecture that I do, I try to include some of my heroes, and I don't know whether you have spoken about this before. No? Is that Tada Ando? If let's say you're a fanboy of Tada Ando, and you wanted this concrete look, and one day your client says that there's no budget for concrete, the next best move is to turn to Lamitech, which is laminate. So what is really interesting about this slide is that laminate, you can mimic marble, you can mimic granite, and you can mimic the name too. So if you are desperate enough, you can choose this thing called Hadal concrete, or you can choose Ando concrete. So when your name is being used in catalogs, you will have to be paid royalties. So this brand, Lamitech, should be paying Tada Ando to use his name. And with every Ando lecture, he is always a happy man, smiling all the way to the back. Not lucky. So, have I went through this slide before? So we talked about how you choose materials, the characteristics, and how it influences the form. So the material shouldn't be a spectator. The elements should also contribute to the workings of the details, not just as a spectator. So we are talking about this, back to this slide again, how much money I've got, what are the practicalities, and what are the maintenance issues when you're going to talk about this. So the next question for all of you guys is, form follows crowd participation time. No, form follows finance. Because no money, no talk. Form follows finance. So Carol has written about this. So it is to talk about how much money is then available to you. And then it will influence on what materials you guys might be using. Have I went through this slide before? Okay. Davian Moore? Did I went through this? Okay, cool. So remember, result of Demoron. So you have this, I'm sure I went through this. So, you know, it doesn't reflect the construction. It doesn't tell you a story about this building. So this stone, they are all outside. They are just barely spectators, because within this layer, you have already got this thick layer of insulation already. Anyway, rocks can't insulate you for say your ash. we have went through this, we have went through this, we have went through this, so that's good. We went through this. Okay, Bauhaus. So Miss Vandero comes from the Bauhaus, so at least he's in charge of the school of Bauhaus, so he's one of the culprit lies on the hands. So one of the ideologies that the Bauhaus movement is subscribing to is the extension of the detail as part of the design process. So so for example, a doorknob. So this Bauhaus doorknob is almost iconic to the movement of the modern movement, the Bauhaus international style. Because with a simple design like this, it embodies a lot of ideology that the movement is subscribing to. So remember, the modern movement is about mass production, it's about having that simplicity of the form that's coming together. So when Walter Gropius designs the doorknob for the typical Bauhaus place, he's using the same idea of using simple geometries. But most importantly, that is that moment in time that somebody has considered the idea of mass production at a very fast and a very easy way of simplified geometrical forms. So the doorknob is then, at least in terms of its geometry, it's aligned with the principle of the Bauhaus movement, and it traces back to its overall idea of Mies and other authors. So this is Denver Art Museum. This is in Colorado, Denver, Colorado. So this is a building designed by Daniel Levitsky. The idea of how this building comes about is actually quite interesting. He has called this project two lines going forward. So he takes the vectors of the Colorado mountains, and he takes the vectors of the cities because they're side by side. And this did a model of these lines crossing one another. So actually it is very formally influenced. It is pretty much stylistic. But anyway, in the extension of the design process, he has designed doorknobs. So he has called this the Denver doorknob. So, but then this is just a mimicry of the original architectural form. So, but still, it's still a design it's still an extension of the design process. So we got rid of that. So let's move on to number two. This one is going to take some time. So, so we're going to talk about construction tolerance. And what do we mean by construction tolerance? And transportation size, the span, the structural loading, as well as maintenance. So the design of the details must be designed to fit, which means that we need to understand that the details must be safe to construct, and when it's being used or when in the process of construction, it also must be safe for the workers to construct. So we are talking about the availability of labor. And as well as the materials that's available to you, as well as the technology available to you. Labor is very sensitive because the labor force that we're getting in, it is, with all apologies to our northern neighbors, it is better than Malaysian laborers. They come from the same place, probably, but the strange thing is that the outcomes of the building is very different. Some of my northern friends are nodding their heads. Okay, you see, we are talking about construction tolerance here. So remember that the drawings that you draw on paper, you may have specified this is 10 mm and this is 10 mm, it's separated by a 5 mm gap. Remember, the construction site is a very difficult place, which means that at least in Singapore, the tolerance is about less than 10 mm. So that means the worker is able to match this. If you say that the gap is 5 mm, it can be 3 mm to 9 mm. Because the materials is here. But in Malaysia, the construction tolerance can be up to 15 mm to 20 mm. So we are talking about construction tolerance, and it goes back to the labor. So I'm moving ahead of myself. If you remember Zaha Hadid's building, Hangzhou Opera House, she has probably designed the details for the labor force found in United Kingdom. She has forgotten that it is all of these Chinese migrants or Chinese people, no offense, but to work out these details. So the locality also plays a part in terms of how are you going to approach the detail. So we talk about workmanship. So when you are working on your drawings, avoid dimensions like 347 mm. So remember, I think some of the reviews in your SDDR, we spoke about this. Try to keep it like a fixed dimension. So if this is going to be 347, you have to round it up to about 350. So if the dimension ends up to be 567, then you have to round it up somewhere else. Because the site, when you are on site, everything changes. So everything is not going to be as prim and proper as the way that you might have thought it. So let's look about this construction tolerance. So it's different construction tolerance for the different materials. So keep that in mind, and the different installation method as well as the different fabrication method. So we're going to see this quickly. Okay. So the idea of detail is that when you see a box which is singly unpretentious, it's just cladded out with bricks. Remember the lesson from the Zaha Lit building is that beneath the surface lies a story of complexity. So even though we see, I see a steel beam, I see this brick box that's resting on top of steel beam, but it can be as complex as this. It could be, for all we know, it might be made out of steel that is being cladded with bricks and having this wall plate to sit on it. So and because even with its simple appearance, the number of trades that's coming in to fix this building involves more than one person. So number one, I need the setting out. I need to build the block work. So that's one trade. That means the brick layers are here. And then the second trade will be the steel. Then the steel guys will be coming in to do the steel and the welding and the bolting. And then the concrete guys will come in to cast the concrete. It's not sequential, by the way. So we're talking about casting of concrete, the curing of concrete, and how do you fix the rebars and how do you take out the formworks. And then we need to understand waterproofing. So another specialist will come in, the waterproofing guys will be coming in to coordinate and then to apply this. And then we have the aluminium guys. The aluminium guys will be coming in to fix your windows and all the bolting. And then you have the brick guys that's coming in again. So this brick guy might be different from this brick guy because this brick guy is fair face brick. So the bricks that you're using here may be the coarse brick, the normal brick, and then this one is the nicer bricks as the facade of the building. So when we take a look at this detail, let's explain a little bit about tolerance and how do you design for tolerance. So even a simple detail like this could end up like this. So what I wanted to point your attention to is this thing. So have you realized that very similar to IKEA instruction unit, you see this thing over here? So this element, this provision of this slot allows you to move this piece left and right. So this is what we call construction tolerance. Because remember, everything on site will not be built exactly for what you have brought. So these are some of the ideas which construction tolerance is then designed into the detail. So for example, if I wanted to understand how I'm going to fix my aluminum cladding, how I'm going to fix my stone cladding, you can move on to the internet to search for the different manufacturers. So like this is one brand, so this is talk about how do you support bricks, so this is like a typical brand, I don't work for them. So anyway, so you move on to their website and to browse through their website, and then you move to a magical area called CAD drawings. So you will download this CAD drawings, and then you can adjust the details a little bit to fit into your own skill. But these are called shop drawings. So we have introduced a couple of drawings. We have introduced construction drawings, which is done by the contractor. We have introduced working drawings, which is done by the architect. So there's this thing called a shop drawing. A shop drawing is done by the manufacturer. So it is a set of drawings that is produced by the contractor, produced by the supplier, produced by the manufacturer, or the fabricator. So this tells you how this can be fixed together. So when you download the drawing, you will look at this. It is very generic. It tells you that I can use concrete. I'll have an expansion bolt over here. I can have this steel profile that is doing this. Then with this, I can start my cladding is over here. And intermittently, in between maybe the course of concrete, I can will be having a cavity, and I need to have this waterproofing here to protect this joint over here. So it seems like an open joint. So a short drawing tells you more or less how these things are being fixed. But it doesn't mean that you wholesale all of this into your own drawings, because they are of a different context. It tells you how this product works, but it doesn't tell you how you should use this product. So that is that. So you don't cut and paste into your own drawings, do not wholesale it. You need to adapt these drawings, you need to change a little bit to make it fit into your context. For all you know, maybe you have another scheme plate that's running around here, so that it changes the whole scheme of the business. So for example, when you're working on a house, so the contractor will appoint a subcontractor. The subcontractor may be the roof specialist guy. So as an architect, you will need to request short drawings from the roof specialist guy. So the roof specialist guy will draw drawings like this, and you working as an architect or in an architecture office will have to take this set of drawings, this set of short drawings, and then sign your line of it. So whatever they have drawn wrongly, you will be liable because you have endorsed this set of drawings. But most of the time, you do not come out with these drawings because you don't specify brands. You try not to specify brands. So for example, because an architect, he has his moral responsibility to act in the interest of your client, not in the interest of your own pockets. Which means that as an architect, you are not allowed to take commission. Which also means that I'm not allowed to specify a brand. So for example, I'm very good friends with you, I'm an architect, you're a roof supplier. I am not allowed to specify your brand. Okay, so that is acting against the interest of the client. So when you are doing your booking drawings, try to avoid the brand. It is not happening. So architecture details, they make or break a project. You know, even if you're as famous as Zaha Hadid, as Guangdong Opera House, you will know that it is not going to work. So, but most importantly, in the education of an architect, in the growth of an architect, it is important for you to travel. Because when you are traveling, it starts to identify what you have seen in the glossy pictures of the zine is actually different from your own experience of the building. So traveling is important. So then the next question is that how do we deem what a good building is? What do we mean by good? What are the relevant metrics for you to measure goodness? So details is one of them, because it is then a fundamental understanding on how this building performs and how the nitty-gritties comes together in the form of the building. We spoke about this, it's the terrible weathering. So the success of the building can only be measured when we are there. So look at the main sequence of the junction. So whatever you have, you can't resolve. So what did the contractor do? You wrap in all of the structural silicon over here and pretend that nothing has happened. And all of these joints, your eyes would have told you that it should meet at one point, but this is then a miscalculation. This is also a miscalculation. And with all of this miscalculation, and you have all of this weathering. And all of this, this stuff that's cooking out. And Kevin McLowe says that there's a lot of things that parametric can't solve. Computation can't solve, which are the level of difficulty. To design for a building to age properly is one of the important things, because as with all propagandas in school, they'll tell you that you're an architect, your buildings will outlive you, so you're leaving a legacy for all your grandchildren to see. There's certain truth in that. But if you realize that in the age of consumerism, you tear down buildings like no tomorrow, so then there is then an ethical responsibility as an architect to advise the client, say that maybe you do not need to build a building, maybe you do not need to tear out the existing building, maybe you can reuse the structure of the building. So anyway, so to design to age properly is important. So Daniel Levitsky is a very interesting character because he used to be an obscure academic living around in schools, Cooper Union and Crab Group. And then he shot to fame one day after winning a competition. So which is the Jewish Museum in Berlin. So that is his first work, but which ends up to be the second project that he has built. this is the second competition that he has won, which is the Felix Nussbaum Museum, which is in Osnabrück. So if this is Germany, but it's not this ship by the way. Berlin is somewhere here, and Osnabrück is all the way to the west. It is very, very close to the Dutch borders. And if you want to take the train, it takes you about 3 hours to do so. And I've missed the train basically. Crap, I didn't manage to go there. It was one of my to-go-to place. So anyway, so Felix Nussbaum Museum was completed in 1998. So when it's being built, it looks like this. So the idea of aging, it is within how Daniel Levitskin has designed this building for, is to age well. Because it's inspired by a portrait of Felix Nussbaum. So Felix Nussbaum is a painter that has not survived, it has done in Auschwitz. So it is based on a self-portrait. So Daniel Levitskin, as a formal exercise, he wanted to take on the hue of the drawing of a certain grayness, something that has deteriorated in time, like our memories they deteriorate in time. So he wanted this building to age well. So this is in the recent years. So you see that the timber has lost its shine. You could see the traces of weathering because it's separated by a metal piece. So you see traces of when it's been new and when it's been old. So when you see this comparison, you understand how long this building has stood. And he has chose this, if I'm not mistaken, it's the same material as the Jewish Museum, which is titanium, aluminium zinc alloy. So aluminium zinc, it gives you that shimmer, but as they age in time, you see these patches of grayness around the material. And of course, concrete itself, it ages by no tomorrow. So if you are to visit this building today, you'll see that it is very, very different from the glossy shots of 1998, which is many years ago. So we are talking about how do you age gracefully. Like when you meet a very old lady on the street, you could see the lines on the face. You could see what are the problems in her walking around. But there's this gracefulness in elderly ladies. You could see the grace. You could feel that, the lines has its traces of time. So it is the same for buildings as well. Buildings are almost like a human being as well. You sound, oh no, King has lost his marbles again. Okay, you mark my words. Okay, when you're a young architect, you design your first building, you've seen the building from nothing to something. And from the very day that you handed over the buildings to your client, it is the day that you are not allowed to visit the building anymore, other than a public building. If you are doing a house, it's the day that you don't go to the site anymore. That is the day you feel depressed, because then this person, this building, you are developed since young. You are no longer allowed to go there anymore. You have no business in that building anymore. So buildings are very much like human beings. They shelter us. There's a certain story that buildings can tell us. So to age with dignity, it is not to age with plastic surgery. That's another thing. Felix Nussbaum Museum, completed in 1998, aged well. Joe Opera House, finished in 2010, didn't age so well. Peter Zumthor has also understood aging. If you look at Peter Zumthor's buildings, so please study his buildings, you realize that his entrances are very small. His entrances are always out of place. His entrances are so weirdly placed. He has a weird idea about entrances. You take a look at it. So even this is like a studio. The entrances is very modest. It is just like a small doorway. It is then expressed out almost like a black box. So when this is open, you could see the grains. But when it has aged inside, you could see the weathering. You could see the steel. So you could see almost like people are stepping on it. So you could see most people are right-footed. So you could tell the story of this building. You could tell how people are using this building. By understanding its wear and tear. This is somewhere quite familiar. I hope you have been to this place. It looks very familiar, but I can't understand. Anyway, this is one of the polytechnics in Singapore. And then T3 and T5 sounds very familiar as well. I think it's empty. Anyway, what do we mean by cosmetic? The building that has been constructed that you see, it is not new. So the construction method that you see are quite contemporary. You see, steel, you see this a very futuristic curve of the roof, of this cladding, all of these little openings that give you ventilation, if it doesn't give you. But before it has went to plastic surgery, it looks like this. Very simple corridor, non-pretentious. It's just corridor so that people don't fall. And then everything seems to be quite, honest for itself. So when the cladding has put up, then this area becomes very stuffy. You get very dingy daylight atmosphere that's coming in. So the idea of having a very wide, airy corridor, because when the class has dismissed, the whole gym gang of you will hang around here. So the architect understood the idea of corridors, but the one who is trying to refurbish to do plastic surgery of this building has failed to understand what is corridor. So with all of the Max Factor, ST Lauder, and SK2, you still end up with great columns like this. So this is to stop the rain, but you end up with funny things like this. So this is like a block plastic surgery that is very important. So let's move on to the limitation of sizes. So when you are trying to annotate your sizes, keep your annotations to a maximum of about 3 meters, because that is the maximum that we should let it is able to take. So, because when the material gets too big, it is very difficult for you to hoist it up and then to construct it. Embodied energy. I'm just going to go through this very quickly. Embodied energy is something that if I have the time, I'd like to go through deeper, but not for today. Embodied energy talks about the energy that is required from the harvesting of the material to the processing of the material to the transportation of the material to the site to the labor that is going to build up your stuff. That is all considered embodied energy. And one last bit of embodied energy is the energy that is required to dismantle the materials from the building. So that it creates this entire life cycle of the material. So I'm not going to go through this, but understand that aluminium has the most embodied energy that you could ever have. So if you want to produce 1 kilo of aluminium, it takes about 155 megajoules to produce aluminium, and it is devastating to the environment. Compared to stainless steel, which takes about 6.7 megajoules to construct, to manufacture. And then wallpaper seems like very harmless. It takes about 36.4 megajoules to construct your wallpaper. So the energy consumption is not so much on where it's being harvested, not how it's being made. It is all considerations on how materials are being made, how it's being manufactured, and how it's being passed to you, and how it's being used as well. So that is ideas of embodied energy. So when you are given a choice, if you want to choose a granite from Indonesia or Malaysia, or do you want to choose a granite from Italy? So then there is something for you to choose, because if I want to choose something from Italy, it gives you the bragging rights, which my friend here will appreciate, but it does not give any mileage to the conservation of energy that leads to which will then lead to a lesser dependency on environmental stress. So there's less stress to the environment. So one important thing is to understand where your materials come from. Is important. Never going to end. Do you guys want a break? Or I just steam through everything? Yeah.